Hello, this is Basar. In this tutorial, we are going to see how the validation is working in Spring. Again, we have a repository for this project, and there are two branches. Once again, the main is the initial project, and the final is what we are going to develop in this tutorial. So let's start with cloning this repository. Running git clone. And opening this folder in Visual Studio Code. Again, let's check the project, the POM.xml first. The Spring Boot version is 2.3.4 and running Java version 11. And again, we are using Spring Data JPA, and we are using this Spring Boot Starter validation. And this is the package we need for this tutorial. And we have this web dependency for adding the REST controller endpoints. And we are using H2 database. And we have the dev tools. And also we have Lombok this time. And this is for generating boilerplate code for us. And you don't have to use it. But if you will, then you have to also update your IDE with it. So in the extensions for the Visual Studio Code, you must be installing this Lombok annotation support for VS Code extension. And that's it. Again, in this project, we have a package of user. There is this user entity, and there is user controller, user service. These are not implemented yet. We are going to implement in this tutorial. And we have this user repository, which is just a basic JPA repository for handling the database operations for this user table. Again, before starting, I just want to highlight how the Lombok is changing our code here in this outline. Here we see the user object has this functions, has this methods, get email, get ID, get password, but we don't see the getters or setters here. And this is because of this annotation, the data. If we just comment it out, and here we see we just have our fields, but we don't have the getter and setter methods for them. So basically, Lombok is generating all these methods for our class. Now let's start with an endpoint for posting user. Starting with the user controller, and this is a REST controller. And in this controller, we will have a method which will be returning back the user object. And let's call this method as create user. And this method will be called whenever a post request is received, the post mapping for this user's endpoint. And in this request body, we will have a user object. And again, we will delegate this operation to user service. So let's inject it first. User service. And we will call user service save method. This method does not exist yet. We will create it. And as a result, it's going to be returning back the saved user object. So we can just directly return it back here. So let's create the method. And in user service, we will implement this method. But first, let's make sure this is a service annotated class. And in this one, we are going to save this user object to database via the user repository. So let's inject user repository. And we will call this user repository's save method with the user object we are receiving in this method. And this is going to be returning back the entity. So that's the implementation. Now let's save all these changes and let's start our application. Now our application is running. Before sending any request, let's just check the console output here. It's not properly printed here, but we have a section right here, this one. It is printing that h2 console available at this /h2-console, and the database name is this one. So first let's connect to the database. Opening the browser, and the application is running at HTTP localhost 8080, and the h2 console is at this path, and just copying this part and pasting here, connecting it, and here we have the user table, and currently it is empty. Now let's post a user. So going to Postman, we will send our request through Postman, and we will send our request to these users, and this was the path we have here, this one, post mapping. So we are going to send the user to this endpoint, and we are going to create a JSON request body, and the user object has, let's open the user object, it has username, email, and password. This ID will be automatically generated by Hibernate when the data is persisted. So we are not going to provide the ID. So we are just going to provide username, email, and password in this request. So let's add them here. Username, let's say user1, email, let's say user1@mail.com, and password is something like that. Now sending the request, we are receiving 200 OK, and we receive this user ID. This is the user object saved to database, and the ID is created by database. And when we go to h2 console and run the select user, here we have the user in database. So that's how the application is working for now. But let's send an invalid request. Let's say we are sending all of these fields empty. Or let's say we are not sending password field at all. So let's send this one. And here we see the user and the email is empty and password is null. So we shouldn't be allowing a user object to have empty fields like this. So each user must have a username, and they must have an email, and they must have a password. So let's do that. Let's go back to our user object, and let's use the validation constraints, not null. So this constraint is not allowing if this username field is null. And let's use same thing for the other two fields. So each field here, username, email, password, cannot be null. And this not null is coming from this package, JavaX validation constraints. So saving this one. And to make sure this not null constraint is applied, we have to tell Spring that in this request body in the user controller, we expect this request body to be valid. So if it's not valid, it's going to be rejecting the request. So again, this valid is coming from this JavaX validation. Now saving the application, and the application is automatically restarted. in each restart, the database name is dynamically generated. So we have another database name right now. We can just copy this one again. Or we can go to Resources, Application Properties, and define the database name we want. So let's say Spring Data Source URL is JDBC h2 mem. Mem is indicating this database is going to be stored in the memory. And let's say our database name is testdb. Saving this one. And the application is restarted once again. Here, let's find the line here. And here we see H2 console available at this path, and the database is this one. So when we go to this URL, now refreshing this one and replacing this part with testdb, connecting, and here we have the user table. And since this database is stored in memory, in each restart the data in it is wiped out, so that's why we have nothing here. Now we have our changes here in user controller for validation, and we have the not null constraint here, and let's try this in Postman. So when we go to Postman and send this request, and we are receiving 400 bad requests, and when we go to the errors part in this response body, here we see the error is occurring for the password field, and it is saying the default message must not be null. But we don't see the other fields because this is empty but not null, so that's why the not null constraint is not working for this one. So let's remove these two fields too and send the request once again. And when we check the errors here, and here we have the email field is failing with this reason, username field is failing with the same reason, and the password field is failing with the same reason. So in user entity, we just added this constraint annotations, and we just tell Spring that we want a request body which is valid. So that's how we are achieving the validation. If you have watched my other tutorial about exception handling in Spring, we have implemented our custom error response body, and we were mapping the exceptions, validation exceptions and the others to our error response. So this was the error object. So let's copy this one, and also we have this error advice. We will copy both of these. Let's start with the API error first. It's going to be under the error package. So copying this part to here and going back to VS Code, creating a new package here under validation. We will have error and our error object, API error, and pasting it here. And to have a getters and setters for each of these fields, we will use data annotation coming with Lombok. And here we have the getters and setters. And also let's copy the error advice here. Creating a new class, error advice Java, and pasting the content here. In that tutorial we were handling this not found exception, but we don't have that one in this case, so removing that part. And here we were mapping the validation triggered exception, which is this one, method argument not valid exception, and we were converting the exception messages to our custom format. So let's save all these changes and see how is the output. So going back to Postman, sending an invalid request, and here we have the validation errors saying the password, email, and username must not be null. Now let's enhance this validation functionality a bit. In user, we are using this not null, but we have other validation constraints, like for instance, we can say we want this username to be within specific size, like it is going to be minimum 3 characters and maximum 10 characters. So we can add multiple constraint annotations for each field. So let's try this one. So the app is restarted and going back to Postman. Now we are going to provide the username, and let's say this is going to be a 2-letter word like this. And this time we are receiving this message for this username validation. So size must be between 3 and 10. These are the values we are setting right here. And you may be asking, where can I find the whole list of the constraints? So for that, you can check the bean validation spec right here. And there is this built-in constraint definitions right here, and corresponding list is here. So we have the null, not null, assert true, and the others. So you can check each of them and decide if any is useful for you. For instance, there is this email, which is perfect for our case. So let's say, so this must be email. So we use email constraint. And that's it. Let's go to Postman and let's send an email, and let's say it is just at Yahoo. So this is a wrong formatted email, sending this one, and here we are seeing the message must be a well-formed email address. If we say something like this, user1@yahoo.com, now we don't see any validation errors for the email case. Now let's think about another scenario, like we want this email to be unique in our application. So each user must have their own unique email addresses. So how we can achieve that? One of the constraint option would be constraint on database level. We can do it by using column annotation, and this is for the persistence package, not the validation. And for this column, we can use the property of unique, and we can set the unique as true. So saving this one. Again, the application is restarted and going back to Postman. Now we are going to send a valid request. So let's say this is user1, and let's say user1@mail.com, and the password is just this one password. So this is valid. Okay, we are sending the request, and here we are receiving this success response. Now sending same request once again, and since there is this user1@mail.com in the database, this request must be rejected. Let's see it. And here we are receiving this internal server error, and we are having this data integrity violation exception. And if we just read the details, we would be seeing it is rejected due to the constraint violation exception. And this is triggered because this email is not unique. So if we just change it to something else and try this one, it would be successfully persisted. So with this way, we are making sure same email address cannot be used for different users. But this solution is not providing the best user experience. So let's try this one. If we have this user1@mail.com, and if we send the request, it's failing. But let's say we are sending a null username, sending this one, and we are receiving this validation error message back. And in this one, it is just saying the username must not be null. But at the same time, this email is also not a valid email because it is in use for other user entry in database. So we must be combining both of these information into the same response. Otherwise, user would be changing its request to make it valid, then sending it to again, and he would be receiving this response, another failure. So we must be providing all the relevant information regarding the validation in the single response. We shouldn't be leading user that there is only one failure, which is just the username is null. If you just fill it correctly, then everything is fine. But then we will be returning this error. And again, this is not an ideal way to inform the user about their actions. So to make these validations to be handled within the same response, we can create our own custom validator for this specific case, checking the existence of the email. So let's create that. Now we are not going to use this column and removing this one. And we are going to create a constraint like this one, not null or email. So let's start with that. First, let's open this not null and let's keep it here. And this is going to be guiding us about how we can create an annotation for validation. So as you can see, this is an interface with @ sign. And that's how we are going to create an annotation. So let's create one. Let's say this is unique email. Again, this is going to be interface. And for the constraint violations, again, we will check the bean validation specification. Here, this part. So you can just check this part about the requirements, and we will just implement one here. So here, like in this not null case, we will have this target and retention, and we will also have the constraint annotations, like this one. I'm just copying all these lines and pasting right here. We don't need the repeatable and the documented. And we will be providing a class right here for our actual implementation, which would be checking if the email is unique or not. So first, this target is defining where this annotation can be used. And we are going to use this annotation right here, like this one, unique email. And this is a field. So we just want this annotation to be targeted in field. We don't need this annotation to be used anywhere else. And this is also required to make sure this annotation to be processed in runtime. And the last one is this validated by, and we are going to have another class. Let's call it unique email validator class. We don't have this class yet. Let's create it here. We will get back to it. And we also have 3 other fields in this constraint annotation. And it is listed right here. The message, like this one, groups, and the payload. And we have this right here for the not null case, just copying it from there and pasting here. And this is the message. We can just replace it with our own message. Let's say this email is in use. So whenever this unique email fails, we are going to be providing this message back to our users in the response. Now let's implement this unique email validator. So this is going to be implementing constraint validator, and this is a generic interface, and it is looking for 2 types, The first one is our constraint, which is unique email, and the second one is the field type. We are going to use this here for this email string, so this is going to be the type of that field, which is string. And we need to implement the method coming with this validator, and that's this one. And whenever Spring is validating the request for this user entity's unique email, it is going to be calling this isValid method with the value of that field, which is the email field for our case. So at this point, we will be checking if this email is in use or not. To make sure this email is in use or not, we need to query it in database. So we need this user repository. So let's inject it right here. User repository. And now we need to query the user table based on the value we are receiving, which is email value. So we need to create a new query here. So what we can do is create a just method, which is going to be returning back a user, and we will be returning back by find by this user's email field, and we will be providing the email. Now we can use this one here. Let's say user in DB by calling this user repository find by email with this value. If in DB is null, which means we don't have any user in database having this email, then we can return true. Otherwise, we will be returning false, which means there is a user with this email, so this is not a valid request, so reject it. Now we have a couple of changes, and let's save them all. Now the application will be restarted. Now let's go back to Postman. Again, the database is empty, so the first request will maybe successful. We will see. Let's send it. And here we are seeing an error, validation exception, which shouldn't be happening. So when we go to our Spring console, let's find the reason why it is failing. And here we are seeing a null pointer exception right at this line 15 in this unique email validator. And if we go back to our stack, we can see here the request is coming to our controller. We are passing it to user service, and it is passing to the repo, and this is being triggered while this data is being persisted to the database. So the unique email validator is being run by Hibernate at this step. So this validator is running at a place where we are not expecting it to run. We were expecting it to run before our controller kicks in. So before the request reaches at this point, that validator must be running and doing its work. But now we see it is also working while the entry is being persisted to the database. And it is failing at this line, this user repository find by email, because this injection, we are injecting the user repository through this Spring auto-wired annotation. This is not working at this step because the instance of this unique email validator is being created by Hibernate, and Hibernate does not know anything about the Spring context. Therefore, it's not able to find a user repository somewhere and inject here. Now let's make this flow more visually understandable. We have user controller, we have user service, and user repository. Now we are receiving a request, the post users, and it is coming to create user method in user controller. We are passing it to user service, and user service is passing it to user repository, and in the end it goes to database. And now our validators are working, and it is actually adding 2 more layers to whole flow, like this one. First, the request is received by Spring Validator, and it is validating the request, running all the validators, and if the request is valid, it is allowing request to continue to this user controller method. And the other layer is the Hibernate Validator, which is running after the user repository. Again, this is running all validators before persisting data to database. And there is a difference between these two. In the Spring Validator, the unique email validator is created by Spring. And in the Spring context, we have the user repository. So Spring is able to inject user repository. Therefore, we don't see the null pointer exception occurring when the Spring Validator is running. But on the other hand, on Hibernate Validator, the unique email validator is created by Hibernate, and it does not know anything about the user repository, therefore it cannot inject it. So we must be disabling this second validation control. So we must be telling Hibernate, we don't need you to validate this request. We will be achieving that by using another property right here. We will tell Spring JPA properties JavaX persistence validation mode to none. Let's save this one. Now the application is restarted, and opening the Postman, sending our request. Remember, the database is empty, so this must be successfully saved to database. And here we have the success response, and sending same request once again. And since there is this user with this user1@mail.com, this must be rejected. So sending our request, and here we see the validation errors. It is saying email, this email is in use. So that's how we can implement our custom constraint validator. Now before finishing up this part, let's change our implementation a bit. Let's try to use the optional whenever possible to make sure we are checking the null controls and act accordingly. So just changing this return type to optional of user, and now we need to update this part. Now this is returning back an optional, and we will be returning true if this is not present. So it is present. So if it is present, this means there is a user with this email. So we must be returning false. Otherwise, we must be returning true. So we can just return like this way. If there is no user with this email, if it is not present, then this is a valid request. Saving all changes once again. And going back to Postman. This is the first request. The user is added to database, sending same request, and it is rejected. Now we have confirmed that our custom validator is properly working, and the best part of this solution is we can combine multiple validation failures within the same response. Like, let's remove this username from the request at all. So this would be leading not null constraint to be applied, and it would be leading this username to be rejected with cannot be null or must not be null message. But on the other hand, we have this email in use, so we must be receiving both of these information in the same response body. So let's try that. And here we see the email is failing with this message, and the username is failing with this reason. So with this way, we are able to provide all the necessary information back to user to make that user provide us the valid user data. So this is how we are handling validation in Spring, and this is how we are adding our custom validators to it. Thanks for watching. That's all for the Spring validation handling part, and hope to see you for the next tutorials.